This is Stats, Chapter 1, Section 3. Okay, levels of measure, basically. So this is really important as far as you go into stats, because you have to figure out what tests to do based on the data that you have. So the question is, what data do you have, right? So the way this is arranged is nominal is the worst, or the least amount of stuff that you have, and then the ratio is the best, basically. Okay, so nominal or no, you have nothing or not very much, basically. So that might be things such as names. That could be one thing. It could be labels, right? That could be one thing. It could be descriptions. That could be another thing, right? Any one of those would be. Okay, so that's not very ideal. Can't do a lot with that other than make some pie charts and some other things and bars. So ordinal scale is a little bit better. Order, right? So basically now you have order. Okay, but that's all you have basically is order. That's the only thing you have. So the difference between the data values cannot be determined. So it's like having a rank scale of something, but if let's say I rank something 1 to 5. I mean, what does a 4 actually mean? I have no idea. Well, what's between a 3 and a 4? There's numbers in between. Yeah, but on my ranking scale 1 through 5, do they have any meaning? No, and I can't. They're meaningless, basically. It's a meaningless scale that has an order, right? Otherwise, grades too, A, B, C, D. You can't really break. It's an order, but it's meaningless scale. You know what I'm saying? Interval scale, inter, like in between, inter, right? That has the ordinal part, right? It has the order, right? Can be arranged. Right, but now the values actually have meaning, basically. But the problem is there's no natural zero, no natural starting point. That's the problem. Okay, so basically nothing. I have order. I have order, and the values in between actually have meaning, right? But there's no natural zero. And then ratio scale has everything. Okay, it has an order. The values in between actually mean something, and I have a natural zero, basically. So as you can see here, nominal is the worst, and it gets better as you go up, right? So qualitative is the first two, and quantitative is the second two, basically, right? So qualitative, quantitative, right? And which of these you do, which tests you do in stats are based on what kind of data that you actually have. What's the scale of data that you have, basically? And here's some examples I made up, too, of different things, basically. Okay? Alright, so you look at the TV shows that the students watch in your class, right? Well, those have names, you know what I'm saying, descriptions. I don't know how you would order those, maybe when they come on at night, I have no idea. That's just nominal scale data, level of measurement, basically. Not much to go on, okay? Let's say do a hotel online survey, right? That's a 0 to 5 or 1 to 5, whatever you want. I mean, who's to say what a 3 really means? And what's between a 2 and a 3, and what does it really mean? I have no idea. There's no actual meaning behind it, correct? So there's an order here, just like grades, A, B, C, D, right? Or ranking in a sports game. But, you know, like I'm first place, you're second place, but what's in between? I mean, who knows? There's no meaning. It's just ordinal. Okay? Order. Okay, well, if I record the birth years of famous peoples in your book, yeah, there's values in between because you can be, you know, born 1 day or 1 hour, 1 second before or after the other person. But when's the beginning? When's the natural zero? I have no idea. So plus there's no year zero because it was, you know, 1 AD and 1 BC. There was no year zero. So as to when the beginning actually is, who knows? It's interval because we have an order and the values in between have meaning, but there's no natural zero. Versus carats of diamonds you found in your mine. That is the gold standard in data because you have everything, right? That is the ratio level, basically. Because it has a natural zero. If you find no diamonds, you have no diamonds, zero, right? And you can have 1 carat or 2 carat diamond. You can have a 1.5 carat, 1.2 carat, right? So that it has an order, and the values in between actually have meaning, basically. Okay, so our goal for this section is not only understand data itself, but making tables, because Chapter 2 will be making graphs. So Chapter 1 is vocab and making tables, and we're going to use those tables in Chapter 2 to make the graphs. So what we want to make today is what's called a frequency distribution. Okay? Okay, so frequency distribution is either a table or a graph that shows how the data is distributed, right? So the whole table is called a frequency distribution. The frequency is the actual individual calculations of how frequent something happened, or the counts, basically, right? So you have 3 different types of frequency distributions. You have categorical, which is for your nominal ordinal scale type stuff, we're not going to be making these because you'll be able to read them, and that's it. You can look at some of the examples in the book. We're not making those. We're only making the numeric ones, right? So the numeric ones are either grouped or ungrouped, right? So we're making these. So these are the quantitative, right? So that's the qualitative one up there. This is the quantitative one, right? Okay, so depending on whether it's interval or ratio, you're going to be making these ones. So it's either ungrouped or grouped, basically. So again, the frequency is just the individual counts of how many times, how many times did you get 13? Once. How many times did you get 12? 6 times. So if it's only one thing per group, which is called a class, it's ungrouped. If you have multiple things per class, which is a group, it's a grouped one, basically. We're only going to make one of those. We're going to make a bunch of these because these make more sense. These do not make sense because if there's 50 things, you don't want 50 groups. That doesn't make any sense, basically. Okay, so long story short, frequency is the individual calculation. Frequency distribution is the whole table, right? We're not going to be making the categorical ones. We're only going to be making the quantitative ones, either ungrouped or grouped. We're going to make one of each, basically. And each of those has a subtype, and there are 3 subtypes. There's cumulative, right, which is the running total. Accumulate, so it goes to 6, then plus 1 more is 7, plus 3 more is 10, plus 6 more is 16, plus 8 more is 24, right? So it's a cumulative total, basically. Then you have relative frequency. So I put the frequency on here. This is frequency. This is relative frequency. So 6 out of 100 is 6%, right? 1 out of 20 is 5%, right? So again, this is the relative frequency. The whole table, not including this, is the relative frequency distribution, basically. Okay, so the table is the distribution. The individual calculation is the relative frequency, right? So as soon as you say distribution, you're talking about the whole table. So basically, you have to take the class frequency, right, which is 6, and divide it by the sum of the frequencies, right? Sigma means sum. Right? So in that case, how many total things do I have? Okay? All right, so cumulative is the running total. Relative is the probability. Anytime you see relative, it's probability. And the last one is both together, which is cumulative relative. It's the running total of the probability, right? So I keep adding up all the probabilities till I get to 100%, basically, right? So those are the subtypes, essentially. Okay. So what I made here is essentially a cheat sheet list on how to make these things, which we're going to refer back to later on. Okay, so we need to calculate the smallest and the largest number for each class, basically. Okay, so a class is what they call a group, basically. What's in each group. So 5, right? 5 right here is the lower class limit, and the upper class limit is 9, right? Also, the 10 is the lower class limit, and the 14 is the upper class limit, right? So there's 7 of them are between 5 and 9. As to what they are, I have no idea, basically. So the class interval is either inclusive or exclusive. We don't want to make the inclusive ones. We want to make the exclusive ones. So if my data set is whole numbers, right, I would go to 1 decimal place. If my data is 1 decimal place, I need to make it go to 2. If my data is 2 decimal places, I need my class to go to 3 decimal places, such that, let's say my number is 9.2, right? Let's say that's my number. Where does it go? I don't know, because at 9 and 10 I have no idea. Here, however, it clearly goes into here, doesn't it? 9.2. So it's exclusively in one of the classes. So we want to make these continuous, right, such that the boundary number will make the data in one class or the other, correct? So typically your number would have to be in one or the other, so you need to make sure that these decimals are one more than the actual decimals in your data. But okay, and we don't want to make open-ended ones either, so we don't want inclusive ones. We want exclusive, and we don't want open-ended either. So we don't want 9 or below or above 34.5, because we want to make graphs out of these in the long run, and we can't make graphs that way. Okay, so the class boundaries. So clearly here, 9.5 is a class boundary. I just clicked the wrong thing. 9.5 is a class boundary, right? So that's the number used to separate the two classes. Okay? And then the class midpoint, so what's halfway between 5 and 9? What's halfway between 4.5 and 9.5? So somewhere in there is a midpoint, basically. Okay? So that is the middle of the two classes. So either way, add them up and divide by 2. Whether that's the boundary or the limit, it doesn't matter. So whether you add these and divide by 2 or add these and divide by 2, you're going to get the same answer. Okay, in class width, max minus min divided by number of classes. Well, this width, 5 to 9. Well, if I do 9 minus 5, I get 4, correct? Is that the width? Well, if I think about it, count. 5, 6, 7, 8, 9. Think about that. 5, 6, 7, 8, 9. That is not a width of 4. Don't subtract them. It's not a subtract problem. That's a width of 5, right? Max minus min divided by number of classes, right? Is the formula to get this, basically. So the question is, how did I know how many to put in here? Right? I did the class width formula, basically. And always round up so you don't leave any numbers out, because you want to be inclusive, basically, of the highest value. Okay, the number of classes is tricky. So the number of classes here, what do I have? I have 1, 2, 3, 4, 5, 6. What do I have here? 1, 2, 3, 4, 5, 6. I guess I did 6 every time. 1, 2, 3, 4, 5. I guess 6. Well, who's to say whether I do 6, 7, or whatnot? So when it comes to number of classes, it's either some property that's being dictated, like grades, or 80 to 89 is a B, and I'm saying 90 to 100 is an A, and I'm saying, so there is either some characteristic that dictates the class, or you need some kind of rule or guideline. We are not going to use these two. Those are common ones. We're not going to use this. So unless otherwise specified, right, use the Sturgis rule. Okay. So n is the number of in my data set. So if my data set has 50 values, n is 50. If my data set has 100 values, n is 100. The problem is, this is the way you do it in Algebra 2 and pre-calculus in high school and in college, right? But you can't do little subscripts in Excel. So you use this formula here, which is the change of base formula, to be able to actually type it into the spreadsheet to get the number of classes, right? And use proper rounding there. The only time you need to round up is with the class width, so you get the biggest number and make sure that it falls into the actual class. Okay, so this is essentially a cheat sheet for all the things we need to calculate you can look back at. So what we want to do now is we want to calculate in the next 2 videos. So video 2 is calculating an ungrouped frequency distribution. In video 3, we'll be calculating a grouped frequency distribution. Okay.